Hello, everyone. I hope you're having a fantastic day today. We're going to try and get through this lesson as quick as possible. It is a little long, but I'm going to try and get through it ASAP. So, today, very simple, we're going to learn about the square root and semicircle functions. Up until now, we've been dealing with linear functions, quadratic functions, and trigonometric functions. Today, we're going to learn about the square root and semicircle functions. So first, square roots. So let's look at square roots here. If we were going to build a square root value, let's use some perfect numbers for square roots. So we've got the square root of 0. I know I can take the square root of 1. I know the square root of 4 is pretty easy, and the square root of 9 is pretty easy too. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Now, when you're setting up the square roots, we start at 0, 0 on our graph here, go to 1, 1, 4, 2, and 9, 3. And if you notice, it follows the same shape as our parabola that was on its side. It's up 1 over 1, up 1 over 3, up 1 over 5. So it follows your 1, 1, 3, 1, 5, 1 rule, except now it's flipped. Instead of going up 3 and over 1, we go up 1 and over 3. So it's a square root function. All right, you got your domain, which is going to be 0 to infinity. 0 to infinity, and then you've got your range, which is again 0 to infinity. All right, and from here, a couple of characteristics. It is 1 to 1. We call this function 1 to 1, meaning that it is 1x for every y. There's no repeated values here anywhere. It is increasing always, and it goes through 0, 0. Right? This is the parent function. Everything else is built off of this function. So down here, a couple of graphing situations. We're going to take the square root of x, move it right 5, and up 3. And up 3. So what I can do is actually take these same points and move them right 5 and up 3. So if I start here at 0, 0 and I go right 1, 2, 3, 4, 5 and up 3, here's my new point. And then I can take the point 1, 1, go right 5 and up 3, here's my point. I can take the next point, 4, 2.
Night custodian to the front office, please.
Go right 1, 2, 3, 4, 5, go up 1, 2, 3. And if you notice, it still follows our up 1 over 1, up 1 over 3, and then it'd be up 1 over 4. Domain here goes from 5 to infinity. The range is going to go from 3 to infinity. 5 to infinity on your domain, 3 to infinity on your range. And then you can check them with your calculator, obviously. Number 2. We've got, the square root of negative x. So this negative right here, that tells me it's a y-axis reflection. That means it's going to make my x values negative. And then I know it's going to be multiplied by 2. So again, there's a couple of ways you can do this, but I know that this is multiplying my y's by 2. So it's going to be a vertical stretch by 2. Now, how I know this is I treat the square root just like I treat parentheses. I'm going to say that again. I treat the square root like I treat parentheses. So that's why over here I went right 5 instead of left. That's why here I'm going to flip across my y-axis. Since the 2 is outside the square root, I'm going to treat that like a vertical stretch. So again, my first point was 0, 0. And I'm flipping across the y-axis, which here I am. There we go. If we go to the 1, 1 point, so let's say we were here, right? So my next point is going to be flipped across the y-axis, and now it's going to be twice as tall. So instead of going up 1, we're going to go up 2. All right. And then my next stretch, since I'm going this way, it was 1, 2, 3, and up 1. But I'm going to go up 2 since I'm stretching my y's by 2. And then it was 1, 2, 3, 4, 5, up 1, but now I'm going to go up 2. And here's my function. So everything that we learned, let me graph this a little bit nicer. Everything we learned about graphing quadratics still applies. All those little tips and tricks still apply to this. Your domain here is going to be negative infinity to 0. Remember, that's how far left to how far right to 0. Well, I just did those backwards. Bracket on 0, parentheses on infinity. My range, 0 to infinita. 0 to positive infinity on my y's. All right. So again, just a little exercise on graphing square root functions. But remember, the rules apply to square roots the same that they apply to parentheses back in our last unit. So we're going to build off of what we did on the last unit. Number 3 here, we've got negative 2x, or negative square root of 2x. So I'm going to list off all the stuff that this does here. The negative outside of the square root is a y-axis reflection. The 2 on the x means I'm going to stretch horizontally, or excuse me, shrink horizontally. What am I doing? It's inside the parentheses, so it's the opposite. Shrink horizontally by 1/2. So I start at 0, 0. I'm not moving anywhere left, right, up, or down. Now, beforehand, I did go, since it's negative, I was going to go down 1 and over 1. But since I am shrinking horizontally, I'm going to go down 1 and over 1/2. And then down 1, and instead of over 3, I'll go over 1 1/2. And then down 1, instead of over 5, I'll go over 2 1/2. And then it would keep going in that manner. Now remember, if you forget this, let's say worst case scenario, you forget this and you're like, Mr. Ballard, I have no idea what I'm doing, mass confusion and chaos. You can always just make an XY chart. Worst comes to worst, make one of these things. Attention, night custodians. 0 to infinity. Night custodian to the front office. Negative infinity to 0 on the range. It goes down to negative infinity. The highest it will ever go on the y values, though, is 0. Remember, range is y's. Okay. So, again, if all else fails, who cares? Make an XY chart and just plot points. These are shortcuts I'm teaching you. Square root of 5 minus x. Okay, now this one is a little bit more in depth as far as what we're going to need to do, because first I need to rewrite it as the square root of negative x plus 5. Negative x plus 5. I always want my x first. And then I'm going to rewrite this. Oh my. I don't think there is a night custodian in this building right now. What I was going to say before I was so rudely interrupted, if there is ever a negative in front of x, you must factor it out. You must factor it out. Because what this is going to tell me, the negative x, too light, gives me a y-axis reflection. So instead of opening this away, it's going to open this away. And the negative 5 tells me right 5. So I want you to remember this little note over here. Always make x positive. Robert, it's going to be about 15 minutes. Is that cool? If you want to come back, you can.
Can I talk to you tomorrow?
Yeah, that's fine. Say hi to Robert, everybody. Hi, Robert.
Bye, everybody.
Bye, everybody. All right. So from 0, 0, go right 5. Bam! That's where our new doodad is at. And I'm not changing X, I'm not changing Y as far as shrinking or stretching, so I am going left though because I'm opening up on a Y-axis reflection. So this tells me I go left. Left. Up 1 over 1, up 1 over 3, up 1 over 5. Did I go over too many? 1, 2, 3, 4. Nope. Sweet. These things are always easier to draw them like this. Now I want to stop here and I want to bring up something really quickly. This kind of looks like a parabola. A square root kind of looks like a parabola that's on its side. The problem with that though is if we were to make a parabola on its side, I'm going to do just a quick sketch like this. It no longer is a function. It ceases to pass the vertical line test. So essentially what we're doing, good night. If you in the building, Arroyo. It's getting annoying. Essentially what we're doing is cutting off part of that parabola. So we're making it a function. It was not a function, so now we're making it a function. Domain here is negative infinita to 5. Range is 0 to infinita. Lowest it goes on your y values is 0. Highest it'll go is infinity. All right, number 5. We're going to be writing functions of square roots. I actually like these better than parabolas for a couple of different reasons. I think that they're easier. They're easier to see what they're doing, personally, I think. So, a couple of things here. First, I'm going to write down some stuff that I notice. So I notice it is now below the x-axis. It was up like this. Remember the parent function? Everything we do is based off of this guy. So I notice that it is an x-axis reflection. That means that there is going to be, since it's an x-axis reflection, that means there's going to be a negative outside the square root. And then instead of going down 1 over 1, I'm going down, it looks like 1, 2, 3 over 1. Let's see if that fits. My next point looks like here. Down 1, 2, 3 over 1, 2, 3. Down 1, 2, 3 over 1, 2, 3, 4, 5. So that fits. So I'm making this thing 3 times as tall. Remember, it was down 1 over 1, down 1. It was down 1, down 1, down 1. Now it's down 3, down 3, down 3. And I found that just from finding a bunch of really good, perfect points in here. And then counting the distance. Now it's over 1, down 3. Over 3, down 3. Over 5, down 3. So it's a vertical stretch of 3. Now to write the equation for that, I'm going to combine these two because both of these happen outside of the square root. So it's going to be a negative 3 square root of x. Both of those happen outside of the square root. All right? Next one. Oh, this is a good one. I'm no longer on 0, 0, so I'm going to have some shifting. Looks like I'm going right 4 and up 6. And then let's find some good points here. Here's 1, here's 1, here's 1. So it's down 1 over 1, down 1 over 3, down 1 over 5. So it looks like it hasn't changed vertically or horizontally, stretch or shrink-wise. So I'm good. But I am upside down and I'm going left now. So I want to show it as an x and y-axis reflection. Remember, if I'm upside down, that's making outside the parentheses negative. If I'm going left, inside the parentheses is negative. So it's going to be f of x equals, remember the outside is going to be negative, the inside is going to be negative, but now I have the parentheses. I'm going x minus 4, I'm going right 4, and then outside the parentheses, up 6. And again, check this on a calculator if you're having issues with this. Again, I'm upside down, I'm going left, I'm right 4, and I'm up 6. And the only thing you need to remember is that when you're going left, or when it looks like it's going left, the negative goes outside of x. After that, you're golden. All right, so let's talk semicircles. It says write the equation for a circle with a center at 0, 0 and a radius of 6, and then solve for y. So, I'm not sure if you remember this from geometry, but your circle equation is x squared plus y squared equals r squared. Kind of like the radius of your unit circle. Oh no. Anyway, so your function here for r, since r is 6, you're going to have x squared plus y squared equals 36. And then if you solve for y, so subtract your x squared over, you get y squared equals 36 minus x squared, and square root it. 36 minus x squared. And you have your plus or minus, because anytime that you take a square root of something, you have a positive and a negative. And then what this would look like is a radius of 6, like this. I'm going to do my best impression of a circle here. That's horrible. Close enough. Radius is 6. What you've actually got here are two functions. You've got a positive and a negative function. So you've actually got two functions here. You've got y equals the positive square root of 36 minus x squared, and y equals the negative value of the square root of 36 minus x squared. Now what this means for you, this is the positive side. This is when y is positive. This is the top half of that circle, and this is the bottom half. So the top half, right here, everything above the x-axis is this guy. The bottom half, everything below the x-axis is this guy. So that brings up a really good point. What if you only want one of them, like a semicircle? Only half the circle, that's the positive side of this. An example would be the square root of 36 minus x squared. All right, so what we're going to do is graph that. Now the first thing this tells me, bam, your radius is 6. So I can actually graph this right now. I'm not going to, but I will in a second. What you can pull out of this here, actually, you know what? Yeah, let's go ahead and graph it. Radius of 6, it's at 0, 0, so it looks like this. Something like this, like that. Good semicircle there. Now what I'm going to show you over here, this is not for this equation, but this is for your general example. If you were to plug in a negative value for r into x, you end up with negative r squared, which is r squared. R squared minus r squared is 0. Square root of 0 is 0. Plug in a 0 and you get the 0 squared is 0. Square root of r squared is r. Plugging in r for x and you get 0 again. See what these points are always going to be the same. Negative r comma 0, like if our radius was 6, negative 6 comma 0 is right here. 0 comma 6 is up here. 6 comma 0 is over here. Your domain goes from negative r to r, negative 6 to 6 in this example, and your range goes from 0 to r, 0 to 6. And you can actually graph these on a calculator. You can actually graph this and this together on a calculator, and you can come up with a circle. It's not going to look like one because it's a rectangle on your stuff, but yeah, circle. This is considered an even function because it's a y-axis symmetry. It's increasing from here to here, decreasing from 0 to r. And that goes under characteristics, but that's irrelevant. Excuse me. So very quickly, a couple of examples. I'm going to pull out any information that I can. So 16 minus x squared. First thing I notice, 16. That means my radius is going to be 4. Plus 4 on the outside of the square root. Well, what do you think that does? Same thing it's always done. It moves it up 4. Alright, so instead of my center being 0, 0, now my center is 0, 4. And I'm going to put a little x on this. I use an x because it's not a point, but it's just my center. And then my radius is 4. 1, 2, 3, 4. From here, 1, 2, 3, 4. 1, 2, 3, 4. All right. Domain here is negative 4 to 4. Range is what, 4 to 8? I really enjoy square roots. I mean, to me, they're easier. All you're doing is moving it up, down, left, right, maybe flipping it upside down, stretching it, shrinking it. But these don't go on forever. That's why I like them. I should always be able to see them. Number 9, this 2 right here, it's a vertical stretch of 2. My radius is 3. And it looks like that's all the information they give me. So my center then is going to be 0, 0. Now this one's a little bit different because my radius is 3. Now if I plug a 3 in here, I've got 3 squared, which is 0, or 3 squared, which is 9. 9 minus 9 is 0. Square root of 0 is 0. 2 times 0 is 0. Same thing for negative 3. But if I plug in 0, the square root of 9 is 3 times 2 is 6. So notice, instead of my radius going 3 right here, it stretched it by a factor of 2. So I multiplied my vertical 3, by a 2. So it's going to be a tall semicircle. And again, graph this on a calculator real quick. Look at what it comes up with. Pause the video and do it if you want. I would. I've already seen it, or I would right now. But just for time's sake, I'm going to keep going. So down here, what I'm going to do is, first thing, when I write equations, I'm going to go halfway in the middle. So this is 8 over here, so my middle point, that's my center. So I was at 0, 0, now I'm up 6. So I'm going to write up 6. I can go ahead and do the same thing on 10 while I'm at it. Middle, or 4 to negative 4, so 0, 0. So I'm not going up or down, left or right anywhere. So that's okay. Then let's count the radius. Your radius is 8 here, 8 this way, and 1, 2, 3, 4, 5, 6, 7, 8 this way. So there's no stretching or shrinking. Fantastic. That makes my job easy. So my radius is 8. But it is upside down. That's an x-axis reflection. You can tell because it was up like this. Now it's upside down. So this is the negative side of it. So what this will look like is negative square root r squared, 64, minus x squared, and then outside of it, plus 6. We'll go over horizontal shifts at another time. Those are kind of another monster. Right now it's just vertical shifts. Number 10. Okay, so I came up with a radius of 1, 2, 3, 4 here, radius of 1, 2, 3, 4 here, and 1, 2, 3, 4, 5, 6, 7, 8. So it's twice as tall on the vertical side as it is horizontally. My radius is still 4 though. I always count radius from the middle out. Alright, so apart from that I didn't change anything. It is a vertical stretch by 2, so it's twice as tall. It should have been 4, but it's 8 instead, so it's twice as tall. Y equals 2 square root. That's where my vertical stretch goes, outside the square root. Radius is 4, so 4 squared minus x squared. Fast and furious, I know, but we will get the rest in class tomorrow.